Okay, in this example, we're going to state the domain and range of the function f of x equals 2 minus the square root of the sum of x and 1. To do this, I'm going to use transformations. So I'm going to go ahead and figure out the transformational rules that we've been using all year. Well, inside affects x values in the opposite way. I see x plus 1 on the inside, so I know my transformation rule is going to be x minus 1. Outside affects y and same. We have two things going on the outside. We have this positive 2 here. It's connected by addition and subtraction. So it is, since it's a positive 2, that means I'm going to be taking my y values and adding 2. In addition to that, I have a minus sign in front of the radical. That implies that there is a negative 1 as a coefficient for the radical, meaning negative 1 is connected by multiplication. So overall, my transformation rules for y is going to be y times negative 1 plus 2. And it might help to rewrite this as in a different format. I do that in a different video that uses the same example, so I'm not going to do it here, but it might help to rewrite it in a different format to get the transformations. Once you have the transformations, it just goes back to knowing a little bit about the parent function. Parent function, its graph looks like this. Its graph only exists where x is greater than 0. It exists nowhere over here. Its graph for the domain only exists where x is greater than or equal to 0. For the range, it's a similar fashion. The range, or y values, don't exist down below the x-axis. So the range of the parent function is y greater than or equal to 0. You can use transformations to apply this and change the domain and range. This is not the only way to do this. This is the way I usually handle it. So my rule for x is to take x values and subtract 1. So if I take my 0 and subtract 1, I have x, and 0 minus 1 is negative 1. We do have to stop and think about the inequality for a second. And if you multiply or divide by negative, just like solving inequalities back in Algebra 1, you would have to flip the inequality sign when you have to divide by a negative. So you have to stop and think, did we multiply or divide by a negative? Well, no, we didn't, so we don't have to flip the inequality sign. Now we're going to go transformations for the y. So range, we're multiplying by negative 1, then adding 2. 0 times negative 1 is still 0, plus 2 is 2. So my key point, my number, is going to be 2. However, I multiply the y values by negative. So while that doesn't affect the actual number in the range, it does affect the orientation of the inequality sign. Since I multiply by a negative, I have to flip that inequality sign because there was a reflection in the graph. Now we have our new domain and range.